Imagine settling into the most comfortable position you can find as we embark on a journey through time and possibility. Tonight, we'll explore a world that might have been, an Earth graced not by one silvery companion, but by several moons dancing across our ancient skies. Close your eyes if you wish, and let your mind drift among the stars as we paint pictures of alternative histories written in celestial light. Our story begins not with dramatic revelations, but with the quiet contemplation of orbital mechanics and the soft mathematics of gravity. Like counting sheep, but instead, we're counting moons, each one a gentle guardian in the vast darkness above. Let the familiar become wonderfully unfamiliar as we reimagine the night sky that has watched over humanity since the beginning of time. In the earliest days of our solar system, some 4.5 billion years ago, the cosmos was arranging itself like a vast, slow ballet. Dust and gas swirled in elegant spirals, gradually gathering into the worlds we know today. The young sun, still finding its rhythm, cast its warming light across a disk of material that would eventually become the planets we know. But in our alternative history, the story of Earth's formation takes a slightly different path, one that leads to a more complex gravitational embrace. Picture, if you will, the proto-Earth, still glowing with the heat of its formation, a world of molten rock and primordial atmospheres. In the space around this young planet, debris from the solar system's formation continues its ancient dance. Some of this material is destined to fall to Earth, adding to its growing mass. But other fragments, caught in the delicate balance between falling and escaping, begin to circle our world in elaborate orbital paths. The first moon, let's call her Luna Prima, formed much as our own moon did. From the gentle accumulation of debris following a cosmic encounter, perhaps it was a glancing blow from a Mars-sized object, or perhaps it was the patient gathering of material from Earth's own formation. Luna Prima emerged as the largest of our three companions, about 3/4 the size of our familiar moon, painted in soft grays and pale yellows from ancient volcanic flows long since quieted. Her surface bore the subtle scars of billions of years of patient weathering by solar winds, each crater a memory of the solar system's tumultuous youth. Luna Prima's face, turned eternally toward Earth, displayed a geography of ancient Maria, those vast plains of cooled lava that early astronomers mistook for seas. But unlike our moon's familiar features that suggest a face or a rabbit or various cultural interpretations, Luna Prima's patterns formed different shapes entirely. Perhaps early humans would have seen in her surface the outline of a great tree, its branches spreading across the lunar surface, or maybe a vast eye, watching over the Earth with maternal patience. The second moon, Secundus, had a different origin story entirely. She was a wanderer, captured from the asteroid belt during Earth's formative years when our planet's gravitational influence was still establishing its boundaries. Secundus was smaller than Luna Prima, perhaps half her size, but what she lacked in stature, she made up for in character. Rich in iron oxides, this moon glowed with a faint rust-colored hue, like autumn leaves seen through morning mist, or like the red ochre that early humans would one day use to paint their first artistic expressions on cave walls. Secundus's orbit traced a different path from Luna Prima's journey, slightly tilted and more elliptical, creating an ever-changing celestial choreography. Sometimes she would appear to chase Luna Prima across the sky, growing closer over the course of months before slowly falling behind again. At other times, the two would appear to move in opposite directions, passing each other in the night like ships exchanging silent greetings. The surface of Secundus told a different geological story. Where Luna Prima showed the scars of ancient volcanism, Secundus bore the marks of a body that had never quite grown large enough to fully differentiate. Her surface was a patchwork of different materials, metallic regions that gleamed faintly in the sunlight, contrasting with darker areas rich in carbon compounds. Some regions showed signs of ancient impacts that had excavated material from deep within, creating patterns of rays that spread across her surface like frozen fireworks. The third and smallest moon, Little Tertius, was different still. No bigger than a large mountain range on Earth, perhaps 300 kilometers across, Tertius was more of a captured asteroid than a proper moon. But what Tertius lacked in size, it made up for in proximity and speed. Orbiting much closer to Earth than its siblings, This pearl-like moonlet completed its journey around our planet every few days, racing across the sky like a patient but persistent wanderer. Tertius was a world of extremes. Its small size meant it had never developed a spherical shape, instead remaining lumpy and irregular, like a cosmic potato tumbling through space. One side was dominated by a massive crater, nearly half the diameter of Tertius itself, a wound from an ancient impact that had nearly shattered this small world. The crater's walls caught sunlight in interesting ways, sometimes appearing to glow with an inner light when the angle was just right. Together, these three moons wove patterns of light and shadow that would have profoundly shaped the development of life on Earth. But before we explore those biological implications, let's pause to consider the physics of this arrangement, the delicate mathematical dance that would keep these three bodies in stable orbits for billions of years. The stability of such a system would require precise orbital arrangements. Luna Prima, being the largest, would dominate the gravitational dynamics. Her orbit would be similar to our moon's current path, roughly 384,000 kilometers from Earth on average, completing one orbit every 27 days or so. This familiar rhythm would provide a baseline, a fundamental beat in the celestial symphony. Secundus would need to orbit farther out to maintain stability, perhaps at a distance of 500,000 kilometers, completing her journey around Earth every 40 days. This would place her in what astronomers call a higher orbit, moving more slowly across the sky, taking longer to cycle through her phases. The tilt of her orbit, perhaps inclined at 15 degrees to Earth's equatorial plane, would mean that sometimes she would appear to travel high above the celestial equator, while at other times she would dip below it, creating seasonal variations in her visibility from different latitudes. Little Tertius, racing in his close orbit, might circle Earth at just 100,000 kilometers distance, completing each orbit in only 5 or 6 days. This proximity would make Tertius appear to move visibly across the sky over the course of a single night, rising in the east and setting in the west multiple times faster than the other moons. His irregular shape would mean that he would appear to change size and brightness as he tumbled, sometimes showing his broad face to Earth, other times showing his narrow face to Earth, times appearing as little more than a bright point of light. The gravitational interactions between these three moons would create what physicists call orbital resonances, mathematical relationships between their periods that would help stabilize the entire system. Perhaps for every 2 orbits that Luna Prima completed, Secundus would complete exactly 1.5, while Tertius might complete exactly 10. These resonances would be like cosmic gears, locking the moons into a stable configuration that could persist for geological ages. Now, let us turn our attention to how this triple moon system would have affected the most fundamental force shaping Earth's surface: the tides. Picture, if you will, the ancient seas of Earth responding to this triple lunar influence. Where our single moon creates tides that rise and fall in predictable patterns, 3 moons would have composed something far more intricate: a gentle chaos of overlapping waves and currents. The tidal forces from each moon would combine in complex ways. Luna Prima, being the largest and relatively close, would still dominate the tidal effects, creating the primary rhythm of high and low tides. But Secundus would add her own gravitational voice to the chorus, sometimes reinforcing Luna Prima's pull when the two aligned, other times partially canceling it out when they pulled in different directions. Little Tertius, despite his small size, would contribute rapid variations due to his proximity and quick orbit. Every few days as Tertius raced around Earth, coastal areas would experience what we might call microtides, quick rises and falls of perhaps a meter or so, superimposed on the larger tidal patterns created by the 2 larger moons. When all 3 moons aligned on the same side of Earth, a rare event occurring perhaps once every few years, the combined gravitational pull would have drawn the oceans into tremendous but gradual swells. Not catastrophic walls of water, but rather slow, majestic rises that would have transformed coastal plains into temporary shallow seas for weeks at a time. These grand tidal events would have been predictable, following mathematical patterns that early civilizations would have learned to calculate and prepare for. Consider how marine life would have evolved in response to these complex tidal patterns. In our world, many coastal species have adapted their life cycles to the simple rhythm of our single moon. Grunion fish in California, for instance, time their spawning to coincide with the highest tides of the full and new moons. In a three-moon world, such adaptations would be far more sophisticated. Coral reefs might have grown in terraced formations, like underwater hanging gardens, each level adapted to different phases of the complex tidal calendar. The highest terraces would only be submerged during the grand alignments, hosting specially adapted corals that could survive long periods of exposure. Lower terraces would experience more frequent submersion, supporting different communities of organisms. Some species of fish might have developed internal biological clocks, attuned not to simple day-night cycles, but to the intricate rhythms of three celestial timekeepers. Imagine schools of silverfish that migrate vertically in the water column, following a complex pattern tied to the positions of all three moons. When Luna Prima is full and high in the sky, they might rise toward the surface. When Secundus is new and Tertius is at its closest approach, they might descend to deeper waters. In the tidal pools, those nurseries of evolution, life would have experienced even more variety. The constant but gentle mixing of waters, the regular but complex patterns of exposure and submersion, would have created countless ecological niches. Perhaps evolution itself would have proceeded differently, with life developing more fluid adaptations, more flexible responses to an ever-changing but predictable environment. Some organisms might have evolved to be generalists, capable of thriving under various tidal conditions. Others might have become extreme specialists, active only during specific lunar configurations. Imagine a species of anemone that opens its tentacles only when all three moons are above the horizon, or a type of seaweed that releases its spores only during the brief windows when Tertius eclipses Secundus. The complex tidal patterns would have affected not just marine life, but terrestrial ecosystems as well. Coastal forests would have developed with multiple zones of salt tolerance. Mangrove-like trees might have evolved with elaborate root systems capable of filtering varying levels of salinity. Some trees might have developed leaves that could fold or unfold depending on the tidal situation, conserving water during high salt periods and maximizing photosynthesis when fresh water was more available. Rivers would have experienced more complex estuarine zones, where fresh and salt water mixed in ever-changing proportions. The boundaries between river and sea would have been less defined, more fluid, creating vast transitional ecosystems. Fish species might have evolved to be more euryhaline, capable of tolerating a wider range of salinities, allowing them to take advantage of the constantly shifting aquatic landscapes. Now, let us drift further back in time, to the era when life was just beginning to establish itself on Earth. The presence of three moons would have influenced the very origins of life itself. The complex tidal patterns would have created more numerous and varied little warm ponds, to use Darwin's phrase, where organic molecules could have concentrated and interacted. The regular but complex cycles of wetting and drying in coastal areas would have provided a natural laboratory for chemical evolution. Different combinations of minerals would have been exposed to organic molecules under varying conditions of temperature, salinity, and pH. The three moons would have acted like celestial lab assistants, constantly mixing and remixing the primordial soup, increasing the opportunities for that crucial moment when non-living chemistry transformed into living biology. Perhaps life would have emerged slightly earlier in this three-moon world, or perhaps it would have emerged in multiple locations simultaneously, leading to a greater initial diversity of life forms. The fossil record of such a world would tell a story of life that was, from its very beginning, adapted to complexity and change. As we move forward through geological time, we can imagine how the presence of three moons would have affected the great evolutionary transitions. When life first ventured from sea to land, the complex tidal zones would have provided a greater variety of transitional environments. Instead of a relatively narrow intertidal zone, there would have been a broad gradient of conditions, from permanently submerged to rarely wetted, with countless intermediate states. Early tetrapods, those first vertebrates to develop limbs suitable for land travel, might have evolved more diverse forms. Some might have specialized in the zones that were submerged only during the grand alignments, developing patience and the ability to estivate, to enter a state of dormancy during dry periods. Others might have inhabited the rapidly changing zones influenced primarily by Tertius, evolving quick reflexes and the ability to rapidly relocate as conditions changed. The evolution of flight might have taken different paths as well. With three sources of nocturnal illumination, creating varying levels of nighttime brightness, nocturnal flying creatures would have had more opportunities to evolve. Perhaps bats would have emerged earlier, or maybe other lineages would have developed powered flight to take advantage of the well-lit nights when multiple moons were visible. Birds migrating at night would have had more navigational aids. The complex patterns of three moons moving across the sky would have provided a sophisticated celestial map. Species might have evolved to migrate only during specific lunar configurations, when the arrangement of the moons made navigation most reliable. As consciousness slowly emerged on this three-mooned Earth, early humans would have looked up at a night sky far richer in movement and meaning than our own. The cognitive demands of tracking three separate celestial bodies, each with its own cycle, would have provided evolutionary pressure for enhanced spatial reasoning and mathematical thinking. Let us imagine a small group of early humans, perhaps Homo erectus or one of our other ancestors, sitting around a fire 2 million years ago. Above them, Luna Prima rises in the east, three-quarters full and bright enough to cast distinct shadows. To the south, Secundus hangs like a rust-colored lamp in its crescent phase. And racing across the sky from west to east, opposite to the apparent motion of the stars, little Tertius appears as a bright, swiftly moving point of light. These early humans would have noticed patterns. They would have observed that Luna Prima's cycle was regular and predictable, that Secundus followed a longer rhythm, and that Tertius seemed to dart about like a celestial hummingbird. Without language to fully articulate these observations, they would nonetheless have begun to internalize these rhythms, to anticipate when the night would be bright and when it would be dark. The development of language itself might have been influenced by the need to communicate about these complex celestial patterns. Words for different phases of different moons, terms for various configurations, names for the special nights when particular alignments occurred. All of this would have enriched early human vocabulary and required more sophisticated grammatical structures to express temporal relationships. As our ancestors developed more complex societies, the three moons would have played crucial roles in their organization. Agricultural societies would have needed to track not just the seasons, but the complex interplay of lunar cycles that affected tides, and therefore irrigation in river deltas and coastal plains. The flooding of rivers would have been more complex, influenced not just by seasonal rains but by the varying tidal forces reaching far inland. The ancient Egyptians of our three-moon Earth might have developed an even more sophisticated calendar system. Instead of a single lunar calendar complementing their solar year, they would have needed to reconcile three lunar cycles with the seasonal cycle. Their mathematics would have advanced more quickly, driven by the practical need to predict when the Nile's flooding would be enhanced or suppressed by various lunar configurations. Imagine the pyramids being built according to alignments not just with stars, but with specific configurations of the three moons. The Great Pyramid might have been oriented so that on certain rare nights, the light from all three full moons would illuminate specific passages or chambers. The architectural precision required would have been even greater, the mathematical knowledge more advanced. In Mesopotamia, the birthplace of writing in our world, cuneiform tablets would have contained complex astronomical tables tracking three separate lunar cycles. The base 60 number system that gave us our 60-minute hour and 360-degree circle might have evolved differently, perhaps incorporating factors that made calculating lunar resonances easier. Mathematical concepts like modular arithmetic and cyclical functions might have been discovered millennia earlier. The ancient Greeks, with their love of geometry and rational thought, would have been presented with a more complex celestial puzzle. Instead of simple circular orbits, they would have needed to explain why three moons moved in different ways. Perhaps this would have led them to abandon the concept of perfect circular motion earlier, accelerating the development of mathematical astronomy. Ptolemy's epicycles would have been even more elaborate, or perhaps the complexity would have driven astronomers to seek simpler, more elegant solutions sooner. Aristarchus's heliocentric theory might have gained more support if it could more easily explain the complex dance of three moons around Earth while Earth itself orbited the Sun. The development of navigation would have followed different paths. With three moons providing varying amounts of light and appearing in different parts of the sky, nighttime navigation would have been both easier and more complex. Sailors would have developed sophisticated techniques for determining their position based on the relative positions of three moons rather than just one. Polynesian navigators, those master wayfinders who crossed vast stretches of the Pacific, would have incorporated three lunar cycles into their mental maps of ocean swells and star positions. The stick charts they used to represent ocean swells might have included markers for different lunar configurations that affected wave patterns. Their oral traditions would have contained even more elaborate instructions for reading the night sky. The Vikings, sailing the North Atlantic, would have benefited from the additional illumination during the long polar nights. When all three moons were above the horizon during the Arctic winter, the reflected light from ice and snow would have created an ethereal landscape bright enough for travel and hunting. Their sagas would have spoken of the three celestial sisters guiding warriors across frozen seas. Chinese astronomy, already sophisticated in our world, would have reached even greater heights. The Chinese concept of yin and yang might have evolved into a more complex philosophy, perhaps incorporating a third principle to represent the dynamic balance between three forces rather than two. Their astronomical records, meticulously kept for thousands of years, would have tracked eclipses involving multiple moons, occultations where one moon passed in front of another, and the precise timing of various alignments. The Maya, with their incredibly accurate calendar systems, would have developed even more elaborate mathematical models. Their long count calendar might have incorporated additional cycles based on the orbital periods of the three moons. The Dresden Codex would have contained not just Venus tables, but detailed ephemerides for all three moons, predicting their positions centuries into the future. Think about how the mythologies of the world would have developed differently. Instead of a single lunar deity, pantheons would have featured three celestial sisters, brothers, or perhaps a cosmic family. The relationships between these deities would have reflected the observed relationships between the moons, sometimes coming together, sometimes moving apart, occasionally aligning in grand celestial gatherings. Luna Prima, the largest and most stable, might have been seen as the eldest sister, wise, patient, and protective. Her steady monthly cycle would make her the keeper of women's mysteries, the guardian of childbirth, the measurer of time. In Greek mythology, she might have been associated with Hestia, the goddess of the hearth, providing steady, reliable light for humanity. Different cultures would have assigned different personalities to this primary moon. In Japan, Luna Prima might have been seen as Amaterasu's gentle sister, providing soft light when the sun goddess rested. In Norse mythology, she could have been one of the Norns, the fates who weave the destinies of gods and humans, her regular cycle representing the steady passage of time and the inevitability of fate. Secundus, with her rust-colored face and tilted orbit, could have been the middle sister. Unpredictable but not unkind, associated perhaps with creativity, change, and the arts. Her longer, more eccentric cycle might have been linked to the seasons of inspiration, the ebb and flow of artistic motivation. The ancient Greeks might have associated her with one of the Muses, or perhaps with Hephaestus, the craftsman god, due to her iron-rich, ruddy appearance. In Egyptian mythology, Secundus might have been linked to Set, not as an evil deity, but as a necessary force of change and challenge. Her reddish hue would have connected her to the desert, to the margins of civilization where new ideas and innovations often emerged. Priests tracking her movements might have been the intellectuals and artists of their societies, looking to her phases for signs of when to begin new creative projects. Little Tertius, racing across the sky, would naturally become the youngest sibling, playful, swift, associated with messages, youth, and new beginnings. Mercury-like in his speed, Tertius might have been the messenger of the gods in multiple mythologies. His rapid cycle might have been used to mark shorter periods of time, perhaps even giving rise to a concept similar to our week, but based on his 5 or 6 day orbital period. Children would have been taught to watch for Tertius, to make wishes when he passed overhead. Lovers might have exchanged messages when Tertius was full, believing that the swift little moon would carry their words to their beloved. Merchants and travelers might have considered Tertius their patron, planning journeys to begin when he was waxing, believing his speed would transfer to their ventures. Stories would have emerged explaining why the three siblings traveled at different speeds, why they sometimes gathered together and sometimes wandered apart. Perhaps Luna Prima was searching for something she lost long ago, moving steadily and carefully across the sky. Secundus, following a different path, was helping in the search but looking in different places. And little Tertius was running back and forth between them, carrying messages, trying to coordinate their efforts. Some cultures might have seen the moons not as siblings, but as a family. Luna Prima as the mother, Secundus as the father, and Tertius as their child. The varying distances between them would represent the dynamics of family life, sometimes close and harmonious, other times distant but still connected by invisible bonds of gravity and love. Religious festivals would have been tied to specific lunar configurations. The grand alignment, when all three moons lined up on the same side of Earth, would have been a time of major celebration or solemn observance. Different cultures would have interpreted this event differently, some seeing it as a time when the veil between worlds was thinnest, others as a moment of cosmic harmony when prayers were most likely to be answered. Consider a spring festival timed to coincide with Secundus reaching its closest approach to Earth while Luna Prima was new and Tertius was full. This complex configuration might occur only once every few years, making it all the more special. Preparations would begin months in advance, with priests calculating the exact date, farmers planning their planting around it, and artisans creating special items for the celebration. The architecture of temples and sacred sites would have incorporated sightlines and alignments for three moons rather than one. Stonehenge-like monuments would have been even more complex, with additional stone circles or markers to track the positions of all three celestial bodies. The mathematics required to design such monuments would have been sophisticated, requiring understanding of three different orbital periods and their interactions. At Angkor Wat, the galleries might have been designed so that moonlight from each of the three moons would illuminate different bas-reliefs at specific times, telling a sequential story that could only be fully appreciated by those who understood the complex lunar calendar. The interplay of light and shadow from multiple moons would have created ever-changing patterns on the carved surfaces, making each visit a unique experience. Islamic architecture, with its emphasis on geometric patterns and astronomical alignments, would have incorporated the three lunar cycles into its designs. The patterns in mosques might have included threefold symmetries representing the three moons, and the calls to prayer might have been timed not just to the sun's position, but to specific configurations of the moons as well. In the Americas, the Nazca lines might have included patterns visible only when illuminated by specific combinations of moonlight. Some of the long straight lines might have pointed to rising or setting points of the different moons at significant times in their cycles. The famous animal figures might have been positioned so that moon shadows from nearby hills would complete the images at certain times. Let us now consider how science would have developed in this three-moon world. The scientific revolution that began in the 16th and 17th centuries would have faced different challenges and opportunities. Copernicus, arguing for a heliocentric model, would have had to explain not just the retrograde motion of planets, but the complex motions of three moons around Earth while Earth moved around the Sun. Galileo, turning his telescope to the heavens, would have had three nearby worlds to explore. The surfaces of Luna Prima and Secundus would have been visible in considerable detail, their different geological histories apparent even through his simple optics. He might have discovered that Tertius was not spherical, challenging the assumption that all celestial bodies were perfect spheres. The moons of Jupiter would have seemed less revolutionary when Earth itself had three companions. Kepler's laws of planetary motion would have been tested and refined using observations of three moons. The slight perturbations each moon caused in the orbits of the others would have provided early evidence for universal gravitation. Newton might have developed his law of universal gravitation earlier, or with greater confidence, having three lunar orbits to test his theories against. The three-body problem, the challenge of predicting the motions of three gravitationally interacting objects, would have been not just a mathematical curiosity, but a practical necessity. Mathematicians would have developed approximation methods and computational techniques centuries earlier. The mathematics of chaos theory might have emerged sooner, as astronomers grappled with the long-term stability of the three-moon system. Consider how the Enlightenment would have unfolded with three moons overhead. The clockwork universe metaphor would have been more complex. Not a simple mechanism, but an intricate chronometer with multiple hands moving at different rates. Philosophers might have developed more nuanced views of determinism and free will, seeing in the complex but predictable patterns of the moons a model for how complexity could emerge from simple laws. The Romantic movement, with its emphasis on emotion and nature, would have had three moons to inspire poetry and art. Byron might have written not of a single "she walks in beauty" like the night, but of three distinct feminine presences in the sky, each with its own character and beauty. Painters like Caspar David Friedrich would have had more varied nocturnal lighting to work with, creating landscapes bathed in the mixed hues of different moons. The development of photography would have been influenced by the availability of more nighttime illumination. Early photographers, limited by long exposure times, would have been able to capture night scenes more easily when multiple moons were visible. The interplay of shadows from multiple light sources would have created unique aesthetic opportunities. As we moved into the industrial age, the three moons would have continued to influence human development. The timing of shift work might have been coordinated with lunar illumination. Factories might have scheduled night shifts for times when at least two moons were visible, reducing the need for artificial lighting. The labor movement might have incorporated lunar cycles into their demands for reasonable working hours. The development of artificial lighting would still have occurred, but perhaps with less urgency. Cities would have remained more connected to natural celestial rhythms. The term moonlighting, working a second job, might have had a more literal meaning, with people taking on additional work during the brighter lunar configurations. Agriculture would have remained more complex, with farmers needing to consider not just the solar seasons, but the intricate lunar patterns affecting tides and, they might have believed, plant growth. The Old Farmer's Almanac would have been a more substantial publication, filled with tables and charts tracking three lunar cycles and their agricultural implications. The space age would have presented different opportunities and challenges. With three moons to explore, the space race might have been more elaborate. Perhaps the United States would have aimed for Luna Prima, while the Soviet Union targeted Secundus. Tertius, with its small size and rapid orbit, might have been seen as a stepping stone, a practice target before attempting to reach the larger moons. The engineering challenges would have been different. Orbital mechanics would have been more complex, with three gravitational bodies to consider when planning trajectories. But there would also have been more options: gravitational assists from one moon to reach another, or Lagrange points between different moon pairs where space stations could be positioned. The psychological impact of seeing Earth from three different moons would have been profound. The famous Earthrise photograph would have had three variants, each offering a different perspective on our home planet. Tertius, being closer, would have shown a larger Earth, while from Secundus, the Earth would have appeared to go through more dramatic phases due to the moon's tilted orbit. Mining operations might have been established on different moons for different resources. Luna Prima, with its familiar geology, might have provided helium-3 for fusion reactors. Secundus, with its iron-rich composition, could have been a source of raw materials for space construction. Little Tertius might have served as a communication relay station, its rapid orbit allowing it to maintain contact with different parts of Earth's surface. The search for extraterrestrial life would have been influenced by having three moons to study. If any of them had subsurface oceans maintained by tidal heating from their gravitational interactions, they might have been candidates for harboring life. The discovery of extremophiles on Earth, combined with potentially habitable environments on our own moons, would have made the possibility of extraterrestrial life seem more plausible. Now, let us drift into more philosophical waters and contemplate how human consciousness itself might have been shaped by growing up under three moons. The human brain, evolved to recognize patterns and cycles, would have been trained from birth to track more complex celestial rhythms. Children learning to count might have grouped things in threes more naturally than in pairs. The concept of trinity might have been more fundamental to human thinking than duality. Sleep patterns might have evolved differently, with varying levels of nocturnal illumination depending on lunar configurations. Humans might have developed more flexible circadian rhythms. Perhaps we would have evolved to be truly polyphasic sleepers, with different sleep patterns for different lunar configurations. When all three moons were new and the nights were darkest, we might have slept deeply for long periods. When multiple moons were full, we might have adopted patterns of short naps interspersed with periods of activity. Dreams would have incorporated three moons into their symbolic language. Psychologists studying dreams might have identified lunar archetypes, different aspects of the psyche associated with each moon. Luna Prima might have represented the conscious mind, steady and predictable. Secundus could have symbolized the personal unconscious, following a longer cycle and occasionally revealing hidden aspects of the self. Tertius might have embodied the collective unconscious, rapidly cycling through universal human experiences and symbols. The development of psychology and psychiatry might have incorporated lunar cycles more seriously. Mental health professionals might have tracked their patients' symptoms against the complex lunar calendar, looking for patterns. Some conditions might have been found to correlate with specific lunar configurations, not through any mystical influence, but through the subtle effects of varying light levels and tidal forces on human physiology. Consider how literature would have developed. The three-act structure that dominates Western drama might have been even more prominent, reflecting the three moons above. Epic poems might have been structured in three parts, each associated with a different moon. The Odyssey might have had Odysseus navigating by Luna Prima in the first part, losing his way when relying on deceptive Secundus in the middle, and finally finding his path home by following swift Tertius. The Gothic novel, with its emphasis on darkness and mystery, would have had more nuanced lighting to work with. Instead of the simple dichotomy of dark and light, authors could have created scenes illuminated by different combinations of moons, each creating its own atmosphere. A chase scene might take place under the racing light of Tertius, while a romantic encounter might unfold under the gentle glow of Luna Prima, with Secundus adding a touch of warm color to the scene. Science fiction would have emerged with different themes. Instead of imagining travel to a single moon, early science fiction writers would have created stories about the different cultures that might develop on each moon once they were colonized. They might have imagined wars between the moons, or perhaps a grand alliance of the three lunar colonies against Earth, or vice versa. The cyberpunk genre might have incorporated the complexity of three moons into its aesthetic. The multiple light sources would have created more complex shadows in those neon-lit alleyways, and hackers might have timed their operations to specific lunar configurations, believing that the gravitational effects influenced electronic systems. Music would have developed with different rhythmic foundations. Where Western music is often based on duple or triple meter, a three-moon world might have developed complex polyrhythmic traditions as standard. Composers might have created pieces that reflected the mathematical relationships between the three lunar periods, with different instruments or voices representing each moon. Imagine a grand symphony in three movements, each movement timed to last as long as one complete orbit of one of the moons. The performance would begin with the new moon of Luna Prima and conclude 73 days later when all three moons had completed their respective cycles and returned to their starting positions. Such a piece would be performed only on special occasions, with audiences attending multiple sessions over the months to experience the entire work. Folk music would have incorporated the three moons into its traditions. Work songs might have different verses for different lunar phases, with the tempo changing based on which moon was dominant in the sky. Lullabies might have told stories of the three moons to help children sleep, with the rhythm of the song matching the gentle orbital motion of Luna Prima. Dance traditions would have evolved to incorporate movements representing each moon. Ballet might have included standard positions and movements associated with each celestial body. Slow, graceful movements for Luna Prima, more dynamic and angular movements for Secundus, and quick light steps for Tertius. Folk dances might have involved three concentric circles of dancers, each moving at a different speed to represent the orbital periods. The visual arts would have been profoundly influenced by the complex play of light and shadow created by three moons. Painters would have developed techniques for representing multiple light sources long before the advent of artificial lighting made such scenes common. The chiaroscuro technique might have evolved to be even more sophisticated, with artists like Caravaggio creating dramatic scenes illuminated by three different sources of light. Sculpture would have considered how pieces would look under different lunar illuminations. A sculpture might be designed to cast specific shadows when lit by Luna Prima from one angle and Secundus from another, creating temporary secondary artworks that existed only during certain celestial configurations. Public monuments might have incorporated this principle, revealing different aspects of their meaning as the moons moved through their cycles. Architecture would have evolved to take advantage of the complex lunar lighting. Buildings might have been designed with windows and openings positioned to capture moonlight from all three moons at different times. The interplay of these different light sources through colored glass or carved screens would have created ever-changing interior environments. Gardens would have been designed for nighttime viewing under various lunar conditions. Plants with silvery foliage would have been positioned to catch the light of Luna Prima, while those with reddish leaves might have been placed where Secundus's light would enhance their color. White flowers that bloomed at night would have been especially prized, creating gardens that were as beautiful by moonlight as by sunlight. The development of ecology as a science would have had to account for the complex influences of three moons on natural systems. Ecologists would have discovered that some species synchronized their reproduction with Luna Prima's cycle, others with Secundus, and still others with the rapid passages of Tertius. The interactions between these different temporal niches would have added another layer of complexity to ecosystem dynamics. Predator-prey relationships might have evolved to take advantage of different lunar illuminations. Some predators might have hunted primarily during the dark nights when all moons were new or below the horizon. Others might have been specialized for hunting during the bright nights of multiple full moons, when their prey's shadows would give away their positions. Prey species would have evolved countermeasures, perhaps fur that reflected moonlight in confusing patterns, or behaviors timed to avoid the most dangerous lunar configurations. Bird migration would have been even more precisely timed, with different species departing under different lunar conditions. Ornithologists would have needed to track not just seasonal patterns, but the complex interplay of three lunar cycles to understand and predict migration timing. Some species might have evolved to migrate only during the rare grand alignments, using these events as unambiguous signals that transcended local weather variations. Marine biology would have been especially complex. The larvae of many marine species drift with the currents before settling and metamorphosing into their adult forms. In our world, many times this process to the lunar cycle. In a three-moon world, there would be multiple strategies. Some species might produce larvae continuously, allowing them to take advantage of whatever tidal conditions occurred. Others might have evolved extremely precise timing, releasing larvae only during specific configurations that would carry them to appropriate settling sites. Coral reefs would have shown even more diversity in their spawning strategies. The synchronized spawning events that occur in our world's reefs would have been even more spectacular and complex, with different species timing their reproduction to different lunar combinations. The few nights each year when conditions were perfect for mass spawning would have seen the ocean transformed into a soup of eggs and sperm, with the three moons presiding over the creation of the next generation. The study of animal behavior would have revealed remarkable adaptations to the three-moon system. Nocturnal animals would have had to adapt to highly variable nighttime lighting conditions. Some might have evolved eyes capable of adjusting to a wider range of light levels. Others might have developed behavioral flexibility, switching between different hunting or foraging strategies depending on the lunar configuration. Consider the humble moth, attracted to light in our world, often to its detriment when that light is artificial. In a three-moon world, moths might have evolved more sophisticated navigation systems, able to distinguish between the different moons and use them for orientation while avoiding the confusion of multiple light sources. Or perhaps different species of moths would have specialized, each navigating by a different moon. Bats, those masters of nocturnal navigation, would have evolved different echolocation strategies for different lunar conditions. On bright nights with multiple moons, they might have relied more on vision, saving the metabolic cost of echolocation. On dark nights, their calls might have been more frequent and intense. The acoustic landscape of the night would have varied dramatically with the lunar configuration. Plants, too, would have shown adaptations to the complex lunar cycles. While plants don't directly use moonlight for photosynthesis, many show lunar rhythms in our world. In a three-moon world, these rhythms would have been more complex. Some plants might have timed their flower opening to specific moons, each attracting different pollinators. Night-blooming plants would have had more options, with some flowers opening only for Luna Prima's gentle light, others waiting for the warmer tones of Secundus. The timing of leaf movements, the daily opening and closing that many plants exhibit, might have been influenced by the lunar configuration. On nights with multiple moons, leaves might have remained more open, capturing not light for photosynthesis, but perhaps using the illumination as a cue for other physiological processes. Seeds might have evolved to germinate under specific lunar conditions, ensuring that seedlings emerged when tidal or other conditions were most favorable. Fungi, those often overlooked members of ecosystems, might have evolved unique relationships with the lunar cycles. Some mushrooms in our world release their spores at night to take advantage of calm air conditions. In a three-moon world, different species might have synchronized their spore release with different moons, reducing competition and ensuring that their spores didn't all land in the same places. The forest floor on a night with all three moons visible would have been a patchwork of light and shadow far more complex than anything in our world. This varying illumination would have created numerous microhabitats, each with its own light conditions. Organisms might have evolved to move between these patches as the moons traveled across the sky, following optimal light conditions through the night. Decomposer organisms, bacteria, fungi, and invertebrates that break down dead material, might have shown lunar rhythms in their activity. The varying moisture levels created by complex tidal patterns would have influenced decomposition rates in coastal areas. Inland, the belief that moonlight influenced decay, whether true or not, might have led to different cultural practices around burial and the handling of organic waste. Let us now consider how human culture and society would have continued to evolve in more recent centuries under the influence of three moons. The Industrial Revolution, that great transformation of human society, would have unfolded differently. Factories, as mentioned earlier, might have operated on more complex schedules tied to lunar illumination. But beyond the practical considerations, the very metaphors we use to understand industrialization would have been different. The idea of progress as a linear advancement might have been less prominent in a world where three different cycles were always apparent in the sky. Instead, cultures might have developed more sophisticated concepts of progress as a multidimensional phenomenon, advancing along different axes at different rates, sometimes aligning and sometimes diverging, like the three moons themselves. The development of electricity and artificial lighting would have had a different social impact. The ability to create light independent of the moons would have been revolutionary, but perhaps also more controversial. Some might have seen it as liberation from the tyranny of complex celestial cycles, while others might have viewed it as a dangerous disconnection from natural rhythms that had governed human life for millennia. Cities might have developed different lighting ordinances, perhaps maintaining dark sky areas where the natural illumination of the three moons could still be appreciated. The modern problem of light pollution would have been recognized earlier, as astronomers complained that they could no longer see the subtle details on Secundus's surface or track the tumbling of little Tertius. The women's suffrage movement might have drawn different metaphors from the heavens. Instead of being associated with a single moon, women's cycles and women's power might have been linked to the complex interplay of three celestial bodies, each with its own strength and rhythm. The idea that women were somehow more lunar than men might have been more nuanced, recognizing multiple aspects of femininity reflected in the different moons. The environmental movement would have had different rallying points. The idea of Earth as a single system might have been extended earlier to include the three moons as part of our extended environment. When humans first began to understand their impact on Earth's climate, they might also have wondered whether human activities could affect the moons, or whether changes to the moons, through mining or colonization, could affect Earth. The space race of the 1960s would have been more complex and perhaps more collaborative. With three targets to aim for, there would have been room for more nations to participate meaningfully. Perhaps the European Space Agency would have formed earlier, aiming for Tertius while the superpowers targeted the larger moons. China, Japan, and India might have entered the space race sooner, each choosing their own lunar destination. The cultural impact of landing on three different moons would have been profound. Each moon would have offered a different perspective on Earth, a different vantage point for reflecting on humanity's place in the universe. The photographs brought back would have shown Earth from three distances, three angles, reinforcing both our planet's uniqueness and its cosmic context. Television broadcasts from the moons would have become regular events. With bases on three different moons, there would always be someone looking back at Earth, providing live coverage of hurricanes, volcanic eruptions, and other major events from a celestial perspective. Weather forecasting would have been revolutionized by having observation posts on three different moons. The development of the internet and global communications would have incorporated the moons from the beginning. Satellites might have been supplemented or replaced by relay stations on the moons, especially on fast-moving tertius. The slight delay in Earth-Moon communications would have been a constant reminder of the cosmic scales involved, keeping humanity more aware of its place in the solar system. Social media in a three-moon world would have included constant updates about lunar positions and phases. Apps would have reminded people when rare alignments were approaching, when their birth moon was full, or when the configuration matched that of important historical events. Dating apps might have included lunar compatibility algorithms, matching people based on their preferred moon or their birth lunar configuration. The development of artificial intelligence might have used the three-moon system as a test case for complex predictions. Early AI systems would have cut their teeth on predicting exactly when and where each moon would rise and set, accounting for all the gravitational perturbations. The three-body problem would have been a benchmark for computational power and algorithmic sophistication. Virtual reality experiences would have included historical recreations of important lunar configurations. People could experience what the sky looked like during the signing of the Declaration of Independence, the fall of Rome, or the building of the pyramids, with all three moons in their historically accurate positions. These experiences would have given people a more visceral connection to history. The study of exoplanets, planets orbiting other stars, would have been influenced by our own three-moon system. Astronomers would have been more prepared to discover and understand complex multi-moon systems around other worlds. The search for extraterrestrial intelligence would have considered whether civilizations that evolved with multiple moons might think differently from those with single moons or no moons at all. Climate science would have had to account for the subtle influences of three moons on Earth systems. The complex tidal patterns would have affected ocean circulation in ways that influenced climate. The varying amounts of reflected light from three moons might have had small but measurable effects on nighttime temperatures. Climate models would have needed to incorporate these lunar influences to accurately predict future changes. The Anthropocene, the proposed geological epoch defined by human influence on Earth, might have been defined differently. Perhaps it would have been marked not just by changes to Earth's atmosphere and biosphere, but by the first human artifacts left on all three moons. The idea that humanity had touched every major body in the Earth-Moon system would have been a powerful symbol of our species' impact. Modern philosophy would have grappled with different questions. The mediocrity principle, the idea that Earth and humanity are not special in the cosmic sense, might have been harder to maintain when our planet was attended by three diverse moons, a relatively rare configuration in the solar system. Alternatively, it might have reinforced our cosmic insignificance, showing that even our own cosmic backyard was more complex than we could fully grasp. Bioethics would have faced unique challenges related to the three moons. If life were discovered on any of the moons, perhaps in subsurface oceans maintained by tidal heating, the ethical implications would have been immediate and personal. These wouldn't be distant aliens but neighbors, sharing our gravitational embrace for billions of years. The question of whether and how to interact with such life would have dominated philosophical and practical discussions. The concept of time itself might be understood differently. With three natural timekeepers in the sky, each with its own period, cultures might have developed more sophisticated concepts of multiple simultaneous temporal flows. The Western linear concept of time and the Eastern cyclical concept might have been synthesized into something more complex, perhaps a helical or multidimensional understanding of time's passage. Modern physics might have developed along different paths. The three-moon system would have provided a natural laboratory for testing theories of gravity and orbital mechanics. Small discrepancies between predicted and observed lunar positions might have led to discoveries about general relativity or dark matter earlier in history. The constant presence of a complex gravitational system might have made concepts like curved space-time more intuitive. Quantum mechanics might have found different metaphors in a three-moon world. The idea of superposition, being in multiple states simultaneously, might have been illustrated by the way the three moons could create multiple overlapping shadows, each real but combining into complex patterns. The uncertainty principle might have been understood through the impossibility of perfectly predicting the long-term positions of three gravitationally interacting bodies. String theory, with its requirement for multiple dimensions, might have seemed less exotic to people accustomed to tracking three independent celestial cycles. The idea that reality has hidden complexities beyond what we directly observe would have been reinforced nightly by the dance of the moons. As we contemplate the cultural development of humanity under three moons, we must also consider the aesthetic dimensions of such a world. Fashion might have evolved to incorporate the colors of all three moons, the silver of Luna Prima, the rust of Secundus, and the pearl white of Tertius. Clothing might have been designed to look different under different lunar illuminations, with fabrics that changed color or appearance depending on which moon's light struck them. Jewelry would certainly have incorporated lunar motifs, but with greater complexity. Instead of simple crescent moon pendants, jewelers might have created elaborate pieces showing all three moons in various configurations. Engagement rings might have featured three stones representing the three moons, with their arrangement reflecting the lunar configuration at the moment of proposal. Cosmetics might have been developed for different lunar lightings. Makeup that looked beautiful under Luna Prima's cool light might have appeared different under Secundus's warmer glow. Special occasions timed to specific lunar configurations might have called for particular cosmetic preparations designed to complement that night's celestial lighting. Cuisine might have developed with lunar associations. Different foods might have been considered appropriate for different lunar phases or configurations. Restaurants might have offered special menus for nights when all three moons were visible, with dishes designed to be enjoyed outdoors under natural celestial illumination. The presentation of food might have incorporated plays on shadow and light that only worked under multiple moon illumination. The wine industry might have taken lunar influences even more seriously than they do in our world. With three moons to consider, biodynamic viticulture would have been even more complex. Different grape varieties might have been harvested according to different lunar schedules. Wine labels might have indicated not just the year of harvest, but the specific lunar configuration, with certain alignments considered particularly auspicious. Urban planning would have evolved to accommodate the complex patterns of moonlight. Parks and public spaces might have been designed as nighttime venues, with features that took advantage of multiple moon shadows. Buildings might have been positioned and designed to channel moonlight into public areas, creating naturally illuminated gathering spaces that changed character as the moons moved through their cycles. Transportation systems might have incorporated lunar scheduling. Night trains might have run on schedules tied to lunar illumination, with more frequent service during bright moon periods. Airlines might have preferred certain lunar configurations for night flights, taking advantage of natural illumination for emergency situations. Ships would certainly have continued their ancient practice of navigating by the moon, but with more sophisticated techniques for using three celestial guides. Sports and recreation would have adapted to the three-moon system. Night games might have been played without artificial lights when the lunar configuration provided sufficient illumination. New sports might have evolved that specifically took advantage of multiple moon shadows, perhaps games where players had to manipulate objects to cast specific shadow patterns. Surfing and other tidal sports would have been far more complex, with athletes needing to understand the intricate patterns created by three gravitational influences. The tourism industry would have developed unique offerings around the three-moon system. Certain locations might have become famous for how they looked under specific lunar configurations. Hotels might have been built to optimize views of all three moons, with rooms priced according to their lunar sightlines. Tour packages might have been timed to coincide with rare alignments or particularly beautiful configurations. Adventure tourism would have included lunar experiences, perhaps night climbing when Tertius was full and racing across the sky, providing rapidly changing but bright illumination. Desert tours might have been scheduled for times when Secundus's ruddy light painted the sand dunes in shades of rust and gold. Arctic expeditions might have aimed for periods when all three moons were visible during the polar night, creating a landscape of ethereal beauty. Photography as an art form would have evolved differently. Long exposure techniques for capturing moon trails would have been more complex but also more rewarding, with three separate tracks painting patterns across the sky. Portrait photographers might have specialized in using natural lunar illumination, with different moons providing different moods and effects. Wildlife photographers would have had more opportunities for night shooting under natural light. Cinema would have incorporated the three moons into its visual language from the beginning. Directors would have used different lunar configurations to set different moods. perhaps romantic scenes under Luna Prima alone, action sequences during the chaotic light of all three moons, and mysterious or suspenseful scenes under the rust-colored glow of Secundus. The magic hour that filmmakers prize would have been supplemented by various magic nights, when specific lunar configurations created unique lighting conditions. Animation and special effects would have had to accurately portray the complex shadows and lighting of a three-moon world. Animated films set on Earth would have needed to show accurate lunar phases and positions, as audiences would have been keenly aware of any errors. Science fiction films set on other worlds might have seemed less alien, as audiences were already accustomed to complex celestial mechanics. Video games would have incorporated the three-moon system into gameplay. Strategy games might have included lunar phases as tactical considerations. Role-playing games might have given characters different abilities under different moons. Simulation games would have needed to accurately model the complex tidal systems and their effects on coastal cities and marine ecosystems. Literature would have continued to evolve with the three moons as a constant presence. Poetry would have had a richer vocabulary for describing nighttime scenes and celestial beauty. Haiku might have evolved differently, perhaps with a different syllable structure reflecting the three lunar cycles. Epic poems might have been structured around grand lunar alignments, with each book or canto corresponding to a different phase of a complex celestial dance. Mystery novels might have used lunar configurations as plot devices, alibis proven or disproven by which moons were visible, crimes timed to take advantage of specific shadow patterns, or detectives using their knowledge of lunar cycles to solve seemingly impossible cases. The locked room mystery might have included puzzles that could only be solved by understanding how moonlight from three sources could create unique shadow patterns. Romance novels would have had more varied settings for moonlit encounters. Instead of a single moonlight and roses trope, there would have been multiple romantic traditions, perhaps proposals under Luna Prima, passionate encounters under Secundus, and playful courtship under Racing Tertius. The complexity of human relationships might have been reflected in the complex interactions of the three moons. Science fiction would have explored different themes. Generation ships traveling to other stars might have been designed with three artificial moons to maintain psychological connections to Earth. Stories about terraforming other planets might have included plans to provide them with multiple moons. The discovery of Earth-like exoplanets might have hinged not just on finding worlds in the habitable zone, but worlds with similar multi-moon systems. Children's literature would have been filled with stories about the three moons. Instead of Goodnight Moon, children might have grown up with Goodnight Moons, learning to say goodnight to each celestial companion in turn. Fairy tales might have featured three lunar kingdoms, each with its own character and inhabitants. Educational books would have used the three moons to teach counting, patterns, and basic astronomy. Comic books and graphic novels would have used the visual possibilities of three moons to create stunning artwork. Superhero stories might have included characters who drew power from different moons, or whose abilities waxed and waned with different lunar cycles. The visual representation of nighttime scenes would have been more complex and beautiful, with artists developing techniques to show multiple light sources and overlapping shadows. Music would have continued to evolve under lunar influence. Modern electronic music might have incorporated rhythms based on the mathematical relationships between lunar periods. Ambient music designed for sleep might have been composed to match the slow orbital period of Luna Prima. Dance music might have included rapid beats synchronized with Tertius's quick motion across the sky. Classical music compositions might have grown even more elaborate, with composers creating works that were meant to be performed under specific lunar configurations. Imagine a violin concerto where the soloist's part was timed to coincide with Tertius crossing the sky, while the orchestra represented the slower movements of the larger moons. Opera might have included scenes where the lunar configuration was crucial to the plot, with staging that incorporated projections or lighting effects to simulate different moon phases. Popular music would have incorporated lunar references differently. Instead of Blue Moon or Fly Me to the Moon, the songbook might have included ballads about the three celestial sisters, rock anthems about rare alignments, and folk songs teaching children the names and cycles of each moon. Music festivals might have been scheduled according to lunar configurations, with different stages dedicated to different moons. Jazz, with its emphasis on improvisation and complex rhythms, might have found inspiration in the polyrhythmic patterns of three orbital periods. Musicians might have developed a form of lunar jazz, where the structure of improvisation was based on which moons were visible during the performance. The concept of trading fours might have evolved into trading threes, with musicians alternating solos in patterns reflecting the three moons. The recording industry might have developed differently. Albums might have been designed with track listings that reflected lunar cycles, perhaps 27 tracks for Luna Prima's period, or collections released in sets of three. The concept of the concept album might have emerged earlier, with artists creating works that told stories paralleling the mythological relationships between the three moons. Live performance venues would have been designed with the three moons in mind. Amphitheaters might have been oriented to capture moonlight from all three celestial bodies at different times of the night. Some venues might have specialized in performances during specific lunar configurations, becoming pilgrimage sites for music lovers when rare alignments occurred. As we approach our present day in this imagined three-moon world, we would find a civilization profoundly shaped by celestial complexity. Climate change discussions would include considerations of how alterations to Earth's atmosphere might affect the visibility of the moons. Light pollution would be an even more serious concern, as it would rob humanity not just of starlight, but of the subtle interplay of three different lunar illuminations. Conservation efforts might include dark sky preserves, specifically designed to protect areas where all three moons could be seen clearly. These preserves would be not just astronomical resources, but cultural and spiritual ones, places where people could reconnect with the celestial rhythms that had shaped human evolution and culture for millennia. The COVID-19 pandemic might have unfolded differently in small but significant ways. Lockdowns might have been easier to endure with three moons providing varied nighttime entertainment. People might have found comfort in watching the eternal dance of the moons, a reminder that some things continued unchanged despite the upheaval in human society. Virtual moon-watching parties might have become popular, with people around the world simultaneously observing rare configurations. Mental health professionals might have recommended moon-watching as a form of therapy, with different moons prescribed for different conditions. The steady cycle of Luna Prima might have been recommended for anxiety, providing a sense of stability and predictability. The longer rhythm of Secundus might have been suggested for those dealing with depression, its slow changes offering hope that current feelings would also pass. The rapid movement of Tertius might have been used to help those with attention disorders, providing a natural focal point for restless minds. Education would have incorporated the three moons into curricula from an early age. Children would have learned to identify each moon, understand their different cycles, and predict their positions. Mathematics education would have used lunar calculations as practical examples. History lessons would have included the lunar configurations during important events. Art classes would have taught students how to paint and draw scenes with multiple light sources. Higher education would have included more sophisticated lunar studies. Universities might have offered degrees in comparative selenology, studying all three moons and their interactions. The field of astrogeology would have been more prominent, with three nearby worlds to study in detail. Orbital mechanics would have been a larger part of physics education, as students grappled with the three-body problem and its implications. The gig economy might have incorporated lunar cycles more explicitly. Delivery drivers might have preferred to work during bright moon nights for safety. Freelance photographers might have specialized in capturing specific lunar configurations. Tourism guides might have timed their activities to lunar schedules, offering different experiences under different celestial conditions. Real estate would have valued properties differently based on their lunar exposure. Homes with good sightlines to all three moons would have commanded premium prices. Buildings might have been marketed based on which moonrise or set could be seen from which rooms. Lunar gardens, outdoor spaces designed to be enjoyed by moonlight, would have been important selling points. Insurance industries would have had to account for the complex tidal patterns in their risk assessments. Coastal properties would have been evaluated not just for typical tidal exposure, but for their vulnerability during rare lunar alignments that produced exceptional tides. The timing of these alignments would have been precisely calculated decades in advance, allowing for long-term planning and preparation. Agriculture would have remained more complex and perhaps more sustainable. Farmers accustomed to working with intricate lunar cycles might have been more receptive to other complex ecological interactions. Permaculture and biodynamic farming might have been mainstream rather than alternative, as working with natural cycles would have been ingrained in agricultural tradition. The energy sector might have developed tidal power generation more extensively, taking advantage of the complex but predictable tidal patterns created by three moons. Engineers would have designed systems capable of harvesting energy from multiple tidal frequencies, creating a more consistent power supply than single-moon tidal systems could provide. As we look to the future of this three-moon world, we can imagine how humanity's next steps might unfold. The colonization of the three moons would proceed in parallel, with each moon developing its own culture and identity. Luna Prima, familiar and stable, might become the administrative center, the Switzerland of space. Secundus, with its mineral wealth, might develop into an industrial powerhouse. Little Tertius might become a communications hub and transit point, its rapid orbit making it ideal for relaying information and serving as a launching point for missions to the outer solar system. The terraforming of Mars might be approached differently by a civilization accustomed to complex celestial mechanics. Plans might include capturing additional moons for Mars, or adjusting the orbits of Phobos and Deimos to create more Earth-like tidal effects. The psychological importance of multiple moons would be recognized, and efforts would be made to provide Mars colonists with a familiar celestial environment. The search for extraterrestrial intelligence would consider the role of multiple moons in the development of civilization. SETI researchers might prioritize star systems with planets that have multiple large moons, reasoning that the cognitive challenges of tracking multiple celestial bodies might accelerate the development of intelligence and mathematics. Messages sent to other stars might include information about our three-moon system as a key part of explaining human culture and consciousness. Artificial intelligence developed by a three-moon civilization might think differently. AI systems trained on the patterns and cycles of three moons might be better at handling multiple simultaneous processes, at finding harmony in apparent chaos. The concept of emergence, complex behaviors arising from simple rules, would be illustrated nightly in the sky, possibly leading to different approaches to AI development. Genetic engineering and biotechnology might draw inspiration from the many biological adaptations to the three-moon system. Scientists might study how organisms evolve to track multiple lunar cycles and apply these insights to creating new biological computers or sensors. The complex circadian rhythms of a three-moon world might provide templates for treating sleep disorders or optimizing human performance. As humanity spreads throughout the solar system and eventually to the stars, the three moons would remain a powerful symbol of home. Spacecraft might be designed with viewing ports oriented to see all three moons when departing Earth. The relative positions of the three moons might become a standard part of timestamps, a way of precisely marking when events occurred. Where were you when? Questions would include not just the event but the lunar configuration, adding another dimension to shared memories. Virtual and augmented reality technologies would certainly include historically accurate lunar simulations. People might walk through ancient Rome or feudal Japan with the correct moons overhead for that exact date and time. Games and educational experiences would use the three-moon system to teach everything from basic astronomy to complex orbital mechanics, from ancient mythology to modern poetry. The development of faster-than-light travel, should it ever become possible, might be influenced by insights gained from studying the three-body problem of our moons. The complex mathematics required to predict long-term lunar positions might contribute to understanding the geometries of space-time needed for interstellar travel. The first starships might be named after the three moons, carrying their names to distant suns. As we near the end of our journey through this imagined world of three moons, let us take a moment to appreciate the profound ways in which such a seemingly simple change, adding 2 additional moons to Earth's sky, would have rippled through every aspect of human existence and terrestrial life. From the earliest emergence of life in tidally mixed chemical soups to the latest developments in quantum computing and interstellar exploration, the presence of 3 celestial companions would have shaped our world in countless ways. The rhythms of life, from the cellular to the societal level, would pulse to a more complex beat. The human mind evolved to track and predict the movements of 3 independent celestial bodies, might be better equipped to handle complexity and find patterns in apparent chaos. Our mythologies, philosophies, and religions would reflect a universe of greater nuance, where simple dualities gave way to dynamic triadic relationships. Art, music, literature, and all forms of cultural expression would draw from a richer palette of celestial inspiration. The interplay of three different sources of nocturnal light would have created possibilities for beauty that we can barely imagine. Every sunset would be followed by the question of which moons would rise, in what order, creating what patterns of light and shadow across the landscape. Science would have developed along different paths, with some discoveries coming earlier, as the three-moon system provided natural experiments in orbital mechanics and gravitational interactions. Other insights might have been delayed, as the complexity of three moons obscured simpler underlying principles. The very way we think about cause and effect, about prediction and chaos, about simplicity and complexity, would have been shaped by nightly observations of our celestial companions. Human society would have developed different structures and rhythms: the working day, the agricultural calendar, the timing of festivals and celebrations. All would reflect the intricate dance of three moons rather than the simpler cycle of one. Cities would be designed differently, cultures would value different things, and the human experience of time itself would be more multifaceted. As we prepare to return from this imaginary journey to our own familiar world of a single moon, we might feel a sense of loss for the beauty and complexity we're leaving behind. But we might also feel a renewed appreciation for the elegant simplicity of our actual celestial companion, for the way a single moon has shaped our world in its own profound ways. The thought experiment of three moons reminds us how contingent our world is, how different things might have been with just a slight change in the initial conditions of our solar system. It reminds us that the familiar is not inevitable, that the world we know is just one of countless possible worlds that might have emerged from the cosmic lottery of planetary formation. And now, as you drift towards sleep, you can choose which world to inhabit in your dreams. Perhaps you'll dream of our familiar Earth with its single, faithful moon, following its ancient path across the sky as it has for billions of years. Or perhaps you'll dream of that other Earth, where three moons dance their eternal ballet, where the night sky tells a more complex story, where shadows fall in triplicate and the tides sing a three-part harmony. In either world, the moons continue their patient orbits, marking time on a scale that dwarfs human experience. They were here before us, and they will be here after us, silent witnesses to the brief flowering of consciousness on this small world. Whether one moon or three, they remind us of our place in the cosmos, small, temporary, but capable of wonder at the beauty of the celestial dance above. As your breathing slows and your mind begins to drift, let the image of moons, whether one or three, be your guide into peaceful sleep. Let their ancient light, traveled across the vacuum of space to reach your eyes, be a connection to the vast universe beyond our small world. And let the rhythm of their orbits, whether simple or complex, be the metronome that counts you down into dreams. The moons continue their journey, as they have since long before humans looked up and wondered, as they will long after the last human eyes have closed. In their eternal dance, whether alone or in company, they embody the patience of the cosmos, the slow unfolding of time on scales we can barely comprehend. They are our companions in the darkness, our guides through the night, our reminders that even in the vastness of space, we are not alone. Sleep now, under whatever moons your imagination provides. Let their light, real or imagined, guard your dreams. And when you wake, perhaps you'll look at our familiar moon with new eyes, appreciating both what is and what might have been in this vast universe of infinite possibilities. The story of three moons is ending now, but the dance continues. In your dreams, you might see them still. Luna Prima steady and bright, Secundus painting the world in rust and amber, little Tertius racing across the heavens like a celestial heartbeat. Or you might see our own moon, solitary but sufficient, beautiful in its simplicity, perfect in its imperfection. Either way, the night embraces you, the cosmos continues its ancient rhythms, and somewhere, whether in this universe or another, moons are rising over sleeping worlds, watching over dreamers who look up in wonder at the lights in the darkness, finding in them both questions and comfort, both mystery and home. Rest now. The moons, however many there might be, will still be there when you wake, continuing their eternal dance, marking time in their patient way, reminding us that in the grand scheme of the cosmos, we are all brief visitors, but visitors capable of appreciating the profound beauty of the celestial ballet that plays out above us, night after night, age after age, until the stars themselves grow cold and the universe itself winds down to its quiet end. But that ending is billions of years away. Tonight, there is only peace, only the gentle pull of sleep, only the soft light of moons, real or imagined, guiding you into dreams where anything is possible, where Earth might have 3 moons or 30 or none at all, where the only limit is imagination, and where morning, when it comes, will bring its own light and its own wonders. Good night, under whatever sky your dreams create. May your sleep be peaceful, your dreams be gentle, and may you wake refreshed, ready to appreciate the wonders of whatever world you find yourself in, whether it has 1 moon or 3, or exists only in the infinite possibilities of imagination.